Good morning, everybody. Welcome to class. One final announcement, since we do have the ice storm coming in tomorrow. I expect that campus will stay open for the ice storm. However, I'm not thrilled about driving in it myself. Similar to last Tuesday. So I think what I'd like to do is I'd like to take this class online tomorrow. So you can still show up and bring your computer and come online that way, or you can, maybe if your 9 o'clock class also lets you go online, you could just stay in your dorm room a little bit longer, or you can zoom in from the library. But for all of our safety, you're not required to go out on that slippery ice and come to my class tomorrow. Let's do it online. I'll put a note on the Google Classroom too. If you are worried about slipping on ice, get yourself some yak tracks, or tell your friend or your guardian to get you some yak tracks. You can Google them. They slip on over your shoes and give you traction, just like a yak. Okay. So that's enough announcements. The main one is join Google Classroom, and tomorrow's online. Let's do some problems. If you're keeping up with the book, we've been floating around in chapter 7, picking out problems that look interesting and doing them. Here, we're solidly in 7.6. We're going to be doing some more of these factoring problems where you have a coefficient in front of the square term, which we've did a few, but I think we should do some more to get some good practice. So what am I talking about when I say a coefficient in front of the square term? Something that looks like this. Something that looks like this. Actually, I'll make a donation of some nicer chalk and maybe some colors too. So if you want to write in the board in the future, you can have that. And this stuff can... Oh yeah, who thinks I can make this? No. One more try. Yeah, here we go. Last one. Still, okay. No, I had to go out on a high note, sorry. Well, I guess I don't have to go out on a high note. I should have stopped. Okay, what about, okay, so now it should be back. Okay, great, great. Yeah, it's really unfortunate, especially for the recording for posterity, but what's happening is the Zoom settings are all fine and they look good, but the actual lavalier microphone is just, I guess it's not sending the signal, but when I restart it, it works. So I'll just have to keep an eye on that. Okay. But so as you can see, like I don't have a great process or a great like algorithm or method that's always going to work every time. It's really just sort of some guessing and some detective work. I mean, you start out with the factors that you know, like has to multiply to this one and multiply to that one. But in terms of actually choosing them to get the middle term to work out, like, yeah, there is a formula you can derive, but it's not worth memorizing. It's sort of better to just guess and check it out. So let's try. A couple more. Here's one that says solve the equation with factoring. 5x squared minus 5x minus 30 equals 0. Take a moment. Give it a shot. So for this one, there's probably two different ways that we can look at. One way is to like factor out 5 from each of the 3 terms and then use our normal way of factoring. Another way is to sort of do it what we've been doing, and so like 5 and 1 will multiply out to 5, so let's choose that. And we need things that multiply out to negative 30, yeah. Plus 10. So yeah, let's give it a shot. Let's see what we get. So that middle term would give us negative 3x, and this term gives us 50x. So probably you want to switch them. Maybe you want like minus 10 plus 3, and here we get negative 10 times x. Here we get 15 times x, which is plus 5x. So what if we did plus minus? And now we got 30x, sorry, 10x. Why did I say 30? So 10x minus 15, giving us minus 5x. So yeah, that looks like it's going to work. So after going through those options, and thank you for the 10 and negative 3. And so this is now equal to 0. So our chain of logic kind of goes, this left-hand side is equal to this. And since this is equal to 0, then so is that. And we want to solve this equation, so we want to solve it for x. So whenever you have two things, like one thing and then another thing, multiplied to be equal to 0, you can reasonably conclude that either the second factor is equal to 0 or the first factor is equal to 0. And then you say what possible values of x? Yeah.
I did it by dividing everything by 5, and when I try to multiply my final answer by 5, it gives me something.
Yeah. Let me address that question. So the question was, if you multiply this, if you divide through by 5 first and then solve for x, and then multiply by 5 again, then you'll get an answer that's not quite right. So let me discuss that. And first, let's try to solve like for our two values of x. So we have a baseline. So for this one, I'm getting x equals 3. And so for this one, I'm getting 5x equals negative 10. And therefore, x equals minus 2. I'm getting that by bringing the 10 to the other side. 5x equals negative 10. Then dividing both sides by 5 to give me negative 2. So I think that's the answer. And I think what's happening is that you don't have to multiply it by 5 again. So were your answers 15 and negative 10? Yeah. So that final step of multiplying it by 5 again actually isn't necessary. And let me explain why. So you can factor out 5 from the left-hand side of the equation, and you can get 5 times x squared minus 1 minus 6 equals 0. So you see what I did. If I multiplied, minus 1 times x, you multiply that through, you get 5x squared minus 5x minus 30 equals 0. And then what you can do, if you want is simply divide both sides by 5. Now giving you x squared minus x minus 6 equals 0. So it's totally legitimate. That's what you did. And now you can factor this polynomial, which you can just say, okay, well, they multiply to negative 6. And add up to negative 1. And now you can say, well, and that means that either x minus 3 is equal to 0, in which case x equals 3, or x plus 2 is equal to 0, in which case x is equal to minus 2. And so you end up with the same answer. But what if you didn't divide both sides by 5? Like, what if you kept this here? Then you still have this situation where it's like 5 times this times that equals 0, and you're still in the situation where that means that either 5 is equal to 0, which isn't true, or x minus 3 is equal to 0, which means x is 3, or x plus 2 is equal to 0, which means x equals negative 2. So what turns out to be the case is that you don't need to then multiply your solutions by 5. It's just this sort of thing is like sitting there, and your original division by 5 didn't change your set of solutions. Yeah. And the other cool thing about this is, how are these related? Well, this is x plus 2 multiplied by 5. You can see the 5x plus 10. Or you could have brought this into 5x minus 15. So this like actually teaches us something even else. Like, we factored this as 5x plus 10, but another student could have factored it by saying 5x minus 15 times x plus 2. That's a completely legitimate way of doing it. So like, there's multiple answers to factoring this. Here's one that we found. Here's another one. How did I get this? Because I just looked at 5 times x minus 3 times x plus 2, and I put the 5 with the x minus 3 instead of the x plus 2. So there's no less than 1, 2, 3 different ways to factor this left-hand side that are all the same. So that's what makes factoring kind of cool, but also a little bit frustrating if you're looking for like the answer. There's a myth in pop culture that says in math, it's just you're either right or you're wrong, and you go for the answer. Actually, oftentimes there's many answers that are all like equivalent. They just sort of have different presentations. Cool. Trying to pick a problem for us. So here's one. Let's do an application. So here's like a mathematically modeling a situation. So we've got someone jumping into a swimming pool, right? So you're up here, the water is down there, and you have like jumped you've jumped off the diving board, and you have some amount of height remaining. And that height is a function of time, because when time is equal to 0, you've just jumped off, and then as 1 second has gone by, you're further down. Another second has gone by, you're further down. Have you ever jumped off of something like a chair or a table, and when you feel yourself falling, can you feel how the longer you're in the air, the more you accelerate downwards? Have you ever felt that? You don't have to do it right now, but go to your dorm or something and stand on a chair and jump off of it, and you'll feel there's a brief moment where you're almost suspended and you don't feel much. And as you're going down, you should feel like you're accelerating. It's really true. So in other words, if you are an object, whether you're going off a diving board or dropping a penny or something, you don't fall at a constant rate. The rate at which you fall changes according to the force of gravity. And so what's the formula for the amount of height you have left? It's actually a quadratic. So this is why we one reason why we like quadratics, because they model things like our position over time. when we are being influenced by gravity. And so the equation neglecting wind resistance is minus 16 t plus, well, actually, this doesn't neglect wind resistance, like plus 80. This isn't part of the problem, but this equation basically tells you that you started at 80 feet. So when time is equal to 0, your height is 80. So this last term tells you where you start. This middle term is due to wind resistance. And this term is due to gravity, and it should have been t squared. So your height is like minus 16 t squared. So after 2 seconds, you'll be, 16 times 4, what's that, 56 feet downward. After 2 seconds, you'll be like an extra 16 feet downward, or for 16 feet. So this brings you down because it's negative. This brings you up because the wind resistance is going in the other direction. And this is where you started with. You add it all together to get the total like height that's left. Anyway, that's for physics, that's not for us. All we need to know is that we've got this mathematical model that accurately tells us our height after we've dropped. And so the question is, and so h is in feet and t is in seconds. And so the question is how long is the diver in the air? That's the question. And so I claim that you can do this with factoring like we've been doing. So give it a think, take a minute, and go to work, and then we'll discuss. So let's now take a minute to discuss. So first of all, even without solving the problem, if I want to know how long the diver is in the air, I'm interested in what's the value of time when the diver hits the water. So when the person hits the water, their height should be equal to what number? So think of your height as like starting out at 80, and then when you hit the water, you're at 0, right? So when I'm asking how long is the diver in the air, I'm asking, like another way to restate this is to say, at what time did the diver hit the water? Because if I'm thinking of when you jump as t equals 0, and then my remaining height is like a function of how many seconds have elapsed since I jumped. Maybe I should have made that more clear at the beginning. Then how long is the diver in the air? That's the same thing as saying, well, when the height gets to 0, how many seconds have elapsed? So which t makes it true that 0 is equal to minus 16 t squared plus 8t. Plus 80. Just to go through that like one more time. You should think of height as like a function of time. So height as a function of time, it's equal to minus 16 t squared plus 8t plus 80. So when time is equal to 0, so like as you're jumping, but you're still up here, 0 seconds have elapsed, then you'll get 0 plus 0 plus 80. So that's how I know that you're starting out 80 feet up into the air, because like if no time has elapsed, you haven't fallen at all. But if 1 second has elapsed, then maybe you're like negative 16 plus 8, so negative 8 plus 80. After 1 second has passed, you've fallen 8 feet. So after how many seconds have passed are you at the water? Meaning, how many seconds were you in the air? So in some sense, the hardest thing to understand about this problem is the fact that solving this problem is the same thing as solving this equation for t. That's what we call these mathematical models. We take a physical situation and then use an equation to model that situation. Solve the equation to get information about the thing that we're modeling. Okay, fine. So we need to factor this polynomial in order to solve the equation for t. And in order to help me do that, I could go like 2 numbers that multiply to 16, 2 numbers that multiply to 80. I'm going to try to factor out as much as I can initially to just try to help with the arithmetic. So I'm seeing that the number 8 appears in all 3 terms. So maybe I'll factor out 8, and then I'll get minus 2 t squared plus t plus 10. And so anyone who got to this stage, or even if we're seeing this stage for the first time, how might we factor it? I think like negative 2t and t. And then we need 2 numbers that multiply out to 10 and will give us t as the middle term. So any suggestions? Yeah. Yeah. And which 5 and which was this one 5? Yeah. Plus 5 and plus 2. So we check that out and we get 5 times 2 is 10. We get we get 5 times t is 5t, and 2 times negative 2t is negative 4t, adding them together just to get t, and then negative 2t squared. So yeah, that works out. So we end up with 0 equals 8 times negative 2 times t plus 5 times t plus 2. And that being the case, we know that the product of 3 things is equal to 0. So either 8 is equal to 0, which isn't true, or t plus 2 is equal to 0, which would mean that t is equal to negative 2, or it's true that minus 2t plus 5 is equal to 0. And solving this equation, forgive me for doing it in my head, bring the 5 to the other side, giving me minus 2t equals negative 5, so therefore t equals 5 halves. 5 halves would be 2.5, right? So I'm getting 2 answers, t equals negative 2 and t equals 2.5. I can immediately reject one answer as not being relevant to my physical situation. Which answer is not relevant to my physical situation? Yeah. I think maybe the negative 2, because time should be amount of time that's elapsed. Yeah, because I'm thinking of like number of seconds starting like 0, 1, 2. Whereas t equals negative 2 would certainly make sense, but that would be like if you could go backwards in time and like go in that direction. So actually, I think we like this one. And this tells us that after 2.5 seconds have elapsed, we have fallen 80 feet. And this is a pretty reasonable physical model, even though that seems like a long time to fall in, like a long distance to fall in 2.5 seconds. It's what happens. So you're starting to see why we even study algebra in the first place. Because if you want to be like Isaac Newton, so Isaac Newton realized that this equation was true in the first place, but if you want to be like Isaac Newton and solve these problems, these mathematical models, what are the ingredients that go into that? Well, the ingredients are, we have to know what's a variable, we have to be able to solve a linear equation, we have to be able to work with quadratic equations, we have to be able to factor those quadratic equations. So even as you're like coming up through class, like why do we care about linear equations? Why do we need to learn to factor? It's because we can use those tools to make mathematical models and then like gain information from it. It's not just because we think that factoring is great and everybody should do it. Like there's, you know, there's like an end goal behind it. Okay. Any comments, questions, or anything from that? Let's do just one more. I know it's close, but we've got a few minutes. Let's do just one more. Let's take, what if we wanted to factor 6x squared plus 5xy minus 4y squared. So the thing that makes this problem hard is that there's 2 variables. The way you can conceive of this is you have to say to yourself, well, let's just treat that variable y like a number. So this is really 6x squared plus number times x minus 4y squared. So if I want to factor this, I can say, well, I need two numbers that multiply to 6 and two numbers that multiply to minus 4y squared. Like for instance, you could use minus 2y and plus 2y. I don't know if that'll work. And then you have something times x. Something times x. So you can kind of just by treating y as a number, you can do the same technique that we've been doing. So take a minute, see if you can fill that in. This may be correct, it may not be correct, and see what you get. Okay, so I'm looking at it. I'm a little confused. Did anybody figure out what numbers you might like?
I don't know. But I put 3x plus -2y.
Okay, cool. So, well, was this like minus? I guess one of them should be minus.
Yeah, first one was.
Yeah, I see. My mistake. So, then I'm seeing minus 4xy, and I'm seeing 6. Yeah, so this maybe gives me 2xy. Yeah. Did you have one, Rosie? Yeah, I got the same thing too. I first tried it. I don't know. I guess it's getting close. Anybody? Then we'll have to leave it overnight. I'm not sure either off the top of my head. But you know what you need to do? It's like 6 and 1, 2 and 3, or like 2 and 2, 1 and 4. So just go through a couple options and see what you get. So have a great day, everybody. Tomorrow will be online class. Stay safe in the ice storm.